This problem says that we have hydrozoic acid, and it's a weak acid. It has an equilibrium constant, Ka, equal to 2.8 times 10 to the negative fifth. We have a 0.3 liter sample, and it's 0.05 molar. So 0.05 molar solution when the acid is prepared. So we want to begin with part A by writing the expression for the equilibrium constant, Ka. So we want to write this equals products over reactants. But in order to do that, we need to be looking at the equilibrium equation. So our acid is HN3 as an acid, so it's going to donate a hydrogen. And the anion left over is N3 minus. So using that, we are able to set up our Ka expression. Again, it's products over reactants. So it's the hydrogen ion times N3 minus. Be careful that you don't do N minus 3 like nitride. This is 3 nitrogens with a -1 charge. And then on bottom, of course, is the original acid, HN3. So that is our part A answer. That is our Ka expression. Now what we're going to do is part B. We are going to calculate the pH of this solution. In order to do that, we need to know the hydrogen ion concentration because pH is the negative log of, make that go away. Sorry, hydrogen ion. In order to find the hydrogen ion concentration of a weak acid, we have to set up a Rice table in order to figure out what that value is. So Rice, HN3, double arrow, the hydrogen ion and the N3 minus ion. We know that our molarity of the acid is 0.05 molar, and the ions, of course, start at 0. We don't know by how much it's going to dissociate or change, so we're simply going to be able to say minus X, and plus X. When we take into account the initial and the change, we have 0.05 minus X, and X. Now, these equilibrium values right here in this line are what we want to plug into the equilibrium expression. However, because it's a weak acid, we can get rid of that value right there, and that's going to make solving this much more simple. So we substitute into the K expression. The Ka value is given, 2.8 times 10 to the negative fifth equals products over reactants. So we have x squared over 0.05. So when we solve this out, we will get our x value, and x, notice, is equal to the hydrogen ion concentration, and when we know that value, to get the pH, we just need to negative log it. So when you do your algebra and solve for x, we get 0.0012 molar, and so if we negative log 0.0012, we get our pH value, and our pH value will be 2.92. So this is our answer for part B. Notice the sig figs. On the pH, it looks like 3 sig figs, 2, 9, and 2, but you have to remember that only the 9 and the 2 are significant. And this means that we've done sig figs correctly because our given values, such as the Ka, which is 2.8, and the molarity, which is 0.050, are 2 sig figs, and that's what limits us. So 2.92 is correct.